Okay, so good morning, everyone. My name is Nicole Jackson. I'm a PhD student working in Megan Konar's group, and so what I'm going to talk to you about in the next couple minutes is some of the work in progress that we've been dealing with to talk about crops, global cropland allocation, and shocks within those croplands for a very long series from 1950 to 2015. So the big question for my personal research that I deal with is looking at how can trade essentially mitigate or exacerbate shocks in the impact of climate shocks in agricultural areas when we're looking at food security. So the way that this question can be broken down is thinking about it in kind of three different domains. So on the far right, we have the trade domain, which is kind of when you're dealing with global relationships, almost trivial to think about because that data is readily available through the UN, through Comtrade. But the two that I'm going to share with you very, very quickly today are thinking about how the environmental or climate system interacts with our agriculture and where crops are grown. And so the reason that these two parts are so difficult to think about is how do you have, for many decades of information that you need, how can you come up with systematic approaches so that you can apply that algorithm and those criteria globally on an annual basis to come up with a systematic way of evaluating our overarching question. So let's see. Oh, I guess we'll just page down. No biggie. So on the left side, it's kind of a summary of how we've chosen to approach evaluating the shocks. So there are four extreme events that we're taking into account. So we've got thermal extremes, so it's either too hot or too cold, and then we have some hydrologic extremes, so either we have heavy rain or we have flooding. So we've got four different shocks, and so compared to previous work, we're at a much higher resolution than previous events. So most of these sets, when you look at extreme events to agriculture, are at a 1/2 degree. So we've been able to move it to a 1/4 degree. And one novelty of this work is to think about, in the absence of tremendous global information at a high spatial resolution of where these crops are grown, we are estimating all of these events by looking at potential land use through the global agroecological zones. And so another way that we've kind of differentiated is, at least for our thermal shocks, is to say, how can we, instead of just looking at deviations from the mean, is to start to think about it from the crop perspective of what are extreme events relative to my maize, relative to barley, and so forth. And so what I'm showing on the right side of the panel is what happens if we take all of our data that we've processed on a daily basis and we aggregate it for our many, many years. And so this is our mean picture of the number of occurrences that we have on an annual basis. And so what you'll see is highlighted some traditional agricultural areas through the world. So the Midwest in the US looks terrible, so it's always full of shocks. But we also see pickup coverage in southern sub-Saharan Africa, parts of Eastern Europe, and South America. So the key here is to think that there's no continent, at least according to our framework, that's immune from these extreme events historically. And so if you're one of those people that looks at historical information for future projections, you could say essentially the same thing, that there's no place in the world going forward that will suffer from extreme climatic events, at least for these 22 major crops that we've looked at. The other thing that we've done is, one thing that we often get asked is, your scale is huge. And so that actually was a red flag for us, in that if you break it down, you almost end up with 4 events per day or some crazy thing, which is too much. So we ended up having what we call an overcounting problem, where we have too many crops coexisting in the same space on the same day, which by and large is not totally representative of the situation. So the schematic on the right kind of shows the big problem that we're tackling with what crops have grown where, to say how can we reasonably estimate co-locating crops at the pixel level. And so what we've come up with is a Monte Carlo approach that basically inputs some slightly dynamic, in terms of temporal resolution, data, and have probabilistically distributed across the world. And so what I'll briefly show, if it works, and I don't know if it will. Oh, well, it was a movie, but the punchline is dynamically what we're able to do is we would have been able to see the number of observations would have actually fluctuated in time because we're developing it based on harvest area. And so what we've been able to capture with a completely probabilistic method is all of the maize that's grown within the Rust Belt, and you'll see it actually intensify in terms of it would have been shown as more red, or it would have extensified. So areas that were blue would have started to transition to red over time to meet the demand of the harvest area. So with that in mind, no, it's cool. I'm on my last slide. So with that in mind, that's basically the work that we have to date. So it's not totally, we kind of actually didn't go with a machine learning approach in this method, so I apologize since it's a machine learning workshop. But what we have been able to do is to come up with some very nice ways of taking literally millions of observations and synthesizing it in a way that's hopefully digestible to people that predominantly economists, since that's kind of the target audience for this work. So with that, I will take one quick question.
Whoever's next can get set up. Well, we have 3 questions. Anybody?
Oh, yeah.
Yeah, I just saw a paper that talked about this. So can you put that in perspective about like what the observations from that paper? You know what paper I'm talking about?
I have no clue what paper you're talking about.
Okay. So
there are tons of papers that deal with extreme events to agriculture.
It was a recent Nature paper that came in and talked about the global food security, the food and the water scarcity. So there was how much of the, I think it mostly dealt with the water, about like problem of like how the water distribution is taking place in terms of the food security. So they looked at it in a global perspective.
Okay.
And gave a nice analysis. So I was thinking whether you had any chance to look at it and maybe comment it in the perspective of the paper. So maybe I can share it with you.
I think I'm vaguely familiar. I've been a little distracted with my prelims, so I apologize. But what I will say is in terms of water, it's incredibly important, especially when you're looking at the hydrologic effects. So even if you have a region that, for example, may have had too much water, with our framework, that could still be damaging to the crop, and so you still end up with a food security issue. Maybe not necessarily on the same scale as a drought, and so in order of the four events that we have examined, flooding was actually, the heavy rain one was actually, had the fewest occurrences, but drought was our second one. So either way you look at it, too much water or too little water, it has historically impacted production, and going forward it will continue to be a huge problem. Any other questions since they're setting up still? Yes.
Where's play?
Or are you stretching?
No, I'm asking a question.
Oh, okay. Sure.
In the allocation, are you strictly, and you may have said this, but are you strictly looking at land currently in crops, or are you also considering land that could be put into crops that's currently not?
It's pretty much potential. And the reason we kind of went with that, one is absence of data, and two, it's just recognizing that something that may have been grown 1 year due to crop rotation may not have shown up. But at least with going through the potential route, you can cover it all since you don't have high resolution of farmer decisions like that.
All right.
Yep.
I got it.
Thanks.
Oh, I'm supposed to wear this.